Hello all, it's time for another round of I Don't Remember How to Do This Stuff with your host, Mr. Mitchell. We're starting today with our linear review. So going back through this, the things that you've been introduced to in middle school and that we've kind of beat you over the head with for a good while now, coming back once again just because it keeps coming back forever and ever. So we're going to go through this little bits at a time, just like we've been doing. Feel free to skip around as you need. If you don't need the whole video, don't have to watch the whole video, but at least take a second to find the answers I go over to make sure the ones you did were correct. As we're doing this here, when we get down towards the bottom down here, looking at equations, I am also going to show you how to use Desmos. Please don't forget that Desmos is available. I know some of you may not have calculators at home, but Desmos will do pretty much everything that your calculator will do, so please don't forget that. Alrighty, let's start on this first one here. So they're wanting us to find slope from a graph. Easiest way to do slope from a graph is to count. Now, you have to remember slope is rise over run. So we're doing the up and down first, and then we're going to do the left and right. Remember, when you're doing that, up is positive, down is negative, left is negative, right is positive. Possible? Whatever that is. It's positive. So we are going to count here, and we're going to take this graph 1, 2, 3, 4, 5, 6, 7 on the rise, and then we're going to go on the run 1, 2, 3. So we had 7 up, that's a positive 7 on top. We had 3 right, that's a positive 3 on the bottom. Our slope is 7 over 3. Easy enough. You do want to check anytime you're doing slope to see if your fraction will simplify. If it does, you should simplify it. If it doesn't, leave it alone. Let's look at our next section here where they're wanting you to find the slope of a line through a pair of points. So you got a couple of options. You've got the trusty equation y2 minus y1 over x2 minus x1. My guys, I also taught you about stack and subtract, where you stack the 2 points and subtract, and remember to put it as y over x when you're done, because that slope is delta y over delta x. That's you're changing y over you're changing x. So all you got to do is stack it up and subtract it, and then remember to put the y values on top and the x values on the bottom. So let me clear that a second. So I went ahead and set up number 4 there. We're going to stack and subtract, and it doesn't matter which one goes on top. And I've actually realized there I've written that incorrectly. Hang on one second. That's more better. Now we're going to subtract. And like I said, it doesn't matter which point you have on top as long as you remember to subtract whatever's on the bottom. So when I go to do this, this is going to be 1 minus negative 5. I can't assume because there's a negative there that I'm already subtracting. It doesn't work that way. I got to make sure I'm subtracting a negative. So when I do that, I got 1 minus negative 5, which gets me 6 as my x value, and 4 minus 18, which gives me negative 14 as my y value. So now I'm going to stack it again. So I'm going to put y over x, so negative 14 over 6. I could divide both of those by 2 easily, and that gets me negative 7 over 3, and negative 7/3 does not simplify, so that is my answer. One easy way to do it. If you got your calculator, you can also remember you can go into your stat edit. Under edit, type in your values under L1 and L2, so x values would go under L1, y values would go under L2. Stat calc option 4, that's len reg ax plus b, and you can go ahead and store it too if you want, but if you're just needing the equation, you don't have to, and go through and hit enter till you get to your main screen where it'll show you y equals ax plus b, where in this case they just use an a instead of an m, and it'll give you the a and the b. The a is your slope, your b is your y-intercept, and that's really helpful when you're finding an equation, but if you're just finding your slope is a quick way to do that as well. So, going to our next setup here. So for number 5 here, what they're wanting us to do is to put it in the form y equals mx plus b. Now this one is almost there already. You would be tempted to start trying to move things, move the x and the 5 over so that you can get the y on the left and everything else on the right. But a real simple thing to do when you already have y by itself is to leave y by itself. And actually, if you're just used to that form, your brain wants it that way, go ahead and rewrite it so that you have negative y equals 5 plus x. Now, we didn't change anything. We just wrote it backwards. Think of that equal sign as like a pivot point, something you can spin it around as long as you keep everything on the same side. And we can even go ahead and rewrite that so we have x plus 5, because as long as we stay on the same side of the equal sign, we can move things around as long as we keep their signs with them. So if it's positive already, it stays positive. If it's negative already, it stays negative. You need to make sure you're doing that as you move terms around. What we're going to do now is get that y completely by itself. If you notice, there's a negative there with it. So we're going to solve that. We're going to divide by negative 1 all the way across. That cancels out that negative 1, and I'm left with y equals, I've got x divided by negative 1 is going to get me negative x. And then I've got 5 divided by negative 1, which is going to get me negative 5. And there I am in slope-intercept form. Okay? Easy peasy on that one. So this one, again, they're wanting us to solve. So what we're going to do is we are going to try to get the y by itself. Now this one, we don't have y by itself already, so we got to try to move things away from the y. I'm actually going to, again, just rewrite it so it's more what we're used to seeing. You don't have to. But I know a lot of you prefer your letters to be on the left and your numbers and stuff to be on the right, or at least the y to be over on the left. So what we're going to do is we're going to start moving things away from the y. Over here on that same side of the y here, we've also got negative x and positive 9. We've also got that negative 3, but we can't move that yet because it's touching the y. So we got to wait until we get all the rest of the stuff out of the way. So what we're going to do first, we're going to inverse operations. We're doing the opposite. So plus x. That cancels out, and I'm left with 9 minus 3y equals x, because 0 plus x is just x. Then I'm going to try to move that 9, an inverse operation again. That's a positive 9, so I'm going to use a negative 9 to move it. Now notice I did not put that negative 9 over here with that x. I put it over to the side, and I did that on purpose because those are not like terms, so we don't want to get those mixed up. And I'm going to move over to the side just a little bit, so hopefully I don't confuse anybody here. That's going to be negative 3y equals x minus 9. And just moving that over to the side because I ran out of room down there at the bottom. Don't want you to try to read it as going over the writing there. And now, last but certainly not least, we got to get rid of that 3y. Well, anytime we have two things that are touching, they're trying to multiply. And the way we keep things from multiplying is by separating them. So we're going to divide these. And the way we divide them is divide by negative 3. And now we divide this whole thing by negative 3. And it may be easier for you to divide each piece by negative 3 to help you remember to do that. But anytime you divide, you got to divide everything on both sides. So what happens, that cancels out that 3 there. And you're left with just a y equals. Now there's a 1 in front of that x. So that's essentially 1 divided by negative 3, which is going to give me negative 1/3 x. I could leave that as x over negative 3, but you'll almost never see it written that way as an answer choice. So that's why I went ahead and wrote it this way. And then I've got negative 9 divided by negative 3, which is going to give me positive 3. So plus 3. Okay? So I've got that there. That's going to be my answer. Box that up there, put a little square around it. Fun fact, you may or may not know that, just for funsies to break things up a little bit, wombats poop in cubes. It's not round like pretty much everything else. They poop in squares. It's a little weird, but throw that out there. Point of trivia, you may or may not know that. All right, let's move along to our next one. All right, number 7 wants us to find the equation of a line through a point with a given slope. So anytime we're looking for the equation of a line, we need two things to write the equation. We need the slope and the y-intercept. Those are m and b. Now, there are 4 parts to the equation. Y is one, m is another, x is another, and b is another. So that's the 4 parts. if we do not have slope and y-intercept, we need 3 of those 4 parts to be able to find any missing part. Generally, what they will wind up doing is giving us either a point and a slope, which is what they've done over here, is giving us a point and a slope, or what they do is give us 2 points, which is what they're doing for the next section there, where you got to find the slope first and then plug it in. Well, we're going to start with the point slope first because that's what we're working with. So what we're going to do is we're going to take y equals mx plus b, and we're going to plug in everything we know. Well, they give us an x and a y over here in the point. So we're going to plug those in where they go. So we got as a y value -3, and they gave me that in the problem, equals m, which they gave me in the problem over here is -2/5. So it gives me -2/5. And then an x value they gave me over here in the problem, they gave me -5. So we had -5 plus b. That's the only thing they didn't give me. That's the only thing that's standing in my way of having my complete equation. So what I'm going to do is I'm going to go ahead and multiply that out. So I get -3 equals -2/5 times -5 gives me +10/5, which is +2, plus b. Now what I'm going to do is I'm going to work on subtracting that 2 from both sides. And I get -5 equals b. Now I'm almost done with that. I now have to take the b that I just found and the m they gave me in my original setup and plug those into my final equation, which is y equals -5, excuse me, I said that wrong. -2/5, because that's my m, x minus 5, because that's my b. Apparently having a little trouble talking this morning. Let's continue on with that. Again, trying to keep the overall size of this video down so that it's not too terrible to watch. Rolling along with our next one, we got 2 points trying to find slope and write my equation. So let me set that up. Okay, first things first when we're doing this is we've got to find our slope because we don't have y-intercept or slope. We've got to have at least one of those to be able to continue on with the equation. So we're going to find slope first. I'm going to use my stack and subtract method, so I'm just going to move this one down because, like I said, it doesn't matter which one's on top. So I've got 1, 1 on the bottom. Just make it a little easier to subtract there. And I subtract that, -5 minus 1 gives me -6. 2 minus 1 gets me 1. And then I've got to do y values on top, so that gives me 1 over -6. This is my slope. This is m. Now I'm going to use that m to write my equation like I did for the last one. Now, I need an x and a y value for this. They give me 2 sets of x and y values. They've got those 2 sets of points there. It does not matter which one I use. So I've got an x and a y and an x and a y. As long as I use one set, it doesn't matter which set I use. I'm going to use the easier one, which in this case would be 1, 1. It really does not matter which one you use. If you want to use -5 too, go for it. I'm going to use 1, 1 just because 1's an easy number to work with. So that gives me a y value of 1. Let's try 1 instead of y. It gives me a y value of 1 equals my m value, which is -1/6, or excuse me, -1/6. So I'm going to write that in, -1/6. And then I have my x value of 1 plus b. So now I'm going to multiply those. So 1 equals -1/6 times 1 gives me -1/6 plus b. I'm going to do my inverse operation to move that. So I'm going to add 1/6 to each side. If I type that in my calculator, I get 7/6. Or you might get the 1/6 as a decimal, which I don't remember off the top of my head. I think it's like 1.6 repeating or something along those lines. It'd be your best interest to go ahead and turn that into a fraction because it makes your life easier. Both your calculator and Desmos will do that. For your calculator, it's math enter. For Desmos, once you get the decimal there, if you look over to the left, there's 2 boxes stacked on top of each other that look kind of like that. And that'll tell you to change it to a fraction. So now that I've got both an m and a b, all I need to do is plug those in the equation. So I've got y equals m, which is -1/6, x plus 7/6, because that's my b value. Okay? So let's look at our next section. Okay, for this next set, I'm actually going to bring up Desmos. And the reason is just because it is so much easier on Desmos. I'm going to show you the quick version going through by hand, but again, this is one of those things that you're rarely going to have to do where you don't have a calculator in front of you. You will occasionally have to do it, but just trying to show you some of the things so you don't forget this. Anytime we've got a table, which is what we've got in number 11 here, and I'm actually going to use it just because a calculator does make this a lot easier. You can, if you're trying to find the line that best fits the data, use a regression. Anytime you see that line of best fit, they're talking about regression. You can do this on your calculator as well if you've got this. If you've got a calculator at home, that's where I mentioned earlier, going to stat, calc, stat, edit. X is under your L1, Y is under your L2, stat, calc, option 4, which is len reg AX plus B, vars, Y vars, enter, until you see your equation. You can also do it here on Desmos, and since most of you have your Chromebooks at home or some other electronic device, it may be easier for you to use that. And what we're going to do first is we're going to click on the plus button right here, and we're going to add a table. So we're going to add that table. We're going to start typing values in. So I'm not going to make you watch me type those values, so hang on a second. Okay, now that I have those points entered in, and that took me a minute, and yes, I used all of it. That's only one column there. They just had to do it in 2 sets just because they didn't have enough room. Same thing over here with number 12. That's actually just one set. They just ran out of room along the bottom there, so they wrote it all in 3 separate sets. So now I've got that typed in there. What I'm going to do is I'm going to set up my regression. Now, my guys, I showed you how to go through and compare R values. I'm hoping other teachers did as well if you didn't have me last semester. But I'm going to show you again because we don't know what type equation this is. Because we haven't done quadratics really yet, that will be coming. We'll have to do that this way where I'll have to do some instruction, but quadratics is coming there. So right now we're really only worried about linear or exponential. This one is actually going to be an exponential because if you look at your values, they get very large very quickly with very little change there. So this is going to almost certainly going to wind up being exponential, which means you really need the calculator to be able to do this. I had said earlier I was going to show you how to do it by hand, but that was before I had gone all the way through this problem here, and that was my mistake. Sorry about that. So I am going to show you, you can still do this with a calculator, and you would do it a similar process. It's just a little bit slower because you can't compare both equations at the same time. So what I'm going to do, I'm going to go ahead and add an equation. So again, I just hit my plus button up top there, and I'm going to add my expression, and I'm going to say y is approximately. Now, remember, we're not using the equals here. We're using approximately. You have on your keyboard this little symbol here. Let me find it. Oops, sorry. Apologies. There it is. This right here, the little squiggle. Yours is under your escape key on your keyboard. It's on this keyboard as well right here if you got your on-screen keyboard. But you need that to be able to type your equation. So I've got y is approximately mx plus b. Sorry, it's taking me a second to get that typed in. Now, if you'll notice, we've still got that exclamation point over there, and that's because it doesn't know where y and x came from. So if you look at your table up there, there's an x1 and a y1. We got to remember to label those. So if you just go beside the y, you can type a 1, and an x, you can type a 1. And you can do that as you're going along. I was just showing you, just typing in that basic equation. And then you've got your R values. So on this one, we're not looking at the R squared, just the R, so it's 0.7001. And gives us that equation, what our M and our B would be if we had that for our regression equation. Now the next thing we're going to do is we're going to go ahead and compare our exponential as well. So what we're going to do is we're going to go y is approximately, y1, a b raised to the x power. Now to do the raised, you're going to have to do the a to the b power over there, top right, and we're going to type it x, and our 1 goes beside that x up there. And I forgot my 1 beside my y there. There we are. So y is approximately ab to the x power. And if we look there, our r values, we got an r squared of a 1. So that's exactly exponential. This one we only have an r squared just because that's what you have with exponentials. Quadratics, the same thing. You've got your r squared. Comparing those, we're not comparing our r values for linear only. We're worried about the r squared for exponential and quadratics. So what it does next is it gives you your equation, gives you your a and b that you would plug in. And yes, I did the more difficult of the two for you, just for this reason. So you got a and b here. So what we're going to do is we're going to write down that equation. So y equals a, which is, we're going to round to the thousandths place, just because we don't have anything that tells us otherwise. So 0.292. And let me actually move that a little bit over where we got a little more room. I'm dealing with number 11. So y equals 0.292 times b, which is 288,742, 288,742 raised to the x power. This is our line of best fit. So it gives us a and b that we got to plug into that equation there. Gives it to us, so it's just a straight plug in. Same thing with number 12. You're going to plug that in and see which one fits the best. And I will go ahead and be nice and tell you that number 12 is going to use your linear. So that first equation we used up top there, the y is approximately mx plus b. That's the one you're going to need for it because number 12 is linear. And it isn't necessarily obvious that it's linear because it comes out to be kind of funny numbers, but that happens a lot in regression if you remember. All right, let's look at what's next here. All right, so this next section here, we've got a couple of things we've got to answer, and some of them we can answer before we do any math. It wants to know, what does the slope of the line represent here in section A? I don't care what you have in a word problem. Anytime you have a word problem and it wants to know what the slope represents, it's going to be your y values per x value. So if you look in this case, this is going to be, and it says in sample. So we got to read a little bit in the problem. Heather collects her coins over a 3-year period. She's collected 100,000 nickels. She found the number of nickels from a given year was related to the number minted that year. So the number in sample we're talking about are the number of nickels she found. And when it says minted in 100 millions, that's how many 100 million nickels were minted that year. So what we have are y values. So looking for that, so the y values are number of nickels. Let's try writing in English. Of nickels collected, or in sample, either one of those would work, per 100 million minted. And I know that may seem a little arbitrary, but that's always the way it works. It's always y per x anytime you need to know what the slope represents. Going down here to this next one, what does the slope of the line represent? That is going to be marriage license per year. Always. That's the way it works. You're going to do marriage license per year. It's always going to be y per x. Is always what does the slope of the line represent. What does the y-intercept of the function represent? Well, y-intercept is where your x value is 0. So that is going to be the number of nickels in her sample. Let me write that out here. So this is B. Write that out there. This is A. Okay. B is the number of nickels in her sample when 0 nickels were minted. Now, obviously, real world here, if we're going with that, if it fits exactly. You remember, equations don't always fit real world exactly. But if it fit real world exactly, if there were 0 nickels minted, there should be 0 nickels in her collection. because if there weren't any minted that year, she couldn't have collected any. But that's not what it's asking. It wants to know what does the y-intercept represent. The y-intercept is always wherever x equals 0. And in this case, our x values are the number of nickels minted in hundred millions. For the rest of this, we need a calculator. So what I'm going to do, I'm going to bring up Desmos. Give me a second to clear this. And I'm going to create a table because I'm trying to find line of best fit. I'm trying to predict things. Anytime I've got the word model or predict or anything along those lines, I'm going to put those, I need a table and do regression. So I'm going to enter my data in. The number minted in millions will be my x values, and the number in the sample will be my y values. Anytime you're setting up a table, they always put the x's on the left and the y's on the right, or if they got it horizontal like this, x is on top and the y is on the bottom. So I'm not going to make you watch me type those in. Give me a second. So I've got those values typed in, and now I need to put in my regression equation. Now, since we've been talking over there about slope, it's pretty safe to assume this is going to be linear. And it actually is on this one. In this case, because we've already got questions about slope on there, the only equation, the only model that has slope is a linear model there. Talking about our linear equation, the y equals mx plus b. And so it's pretty safe to assume that you're going to be using that one for your regression model. Otherwise, we would need to do like we did before and compare our R values and see which one is best, whether it's linear or exponential. But this one, it's safe to go ahead and assume linear, so I'm going to go ahead and do that. Y1 is approximately the little squiggle there, the tilde. Remember, yours is under the escape key as well if you don't want to use the on-screen keyboard. I went away too soon. mx1 plus b. There it is. And if I look there, it gives me my equation. So if I look at my equations, or my problem C, according to the model, how many nickels from a year in which 2,200 million were minted would you expect to find in a sample of 1,000? Round your answer to the nearest whole number. So now we've got our equation. We need to predict with it. Now I got to look, hundreds of millions minted there. That is an X value. So what I'm going to do is go over here to my Desmos, and I'm going to type in X equals what I'm looking for. So X equals, and in this one it wants 22. Now it says in 100 millions, but my table's already in 100 million, so it's going to give me what I need there. So I'm going to say X equals 22, and go ahead and do that. Now here's the tricky part. I need to find where that intersects my line, and with Desmos sometimes that can take a little bit of scrolling. On your calculator, it's really nice because once you've got your regression equation in there and you've stored it with the vars, y vars, enter, what you've got, you can go to your table and go to table set, the second window, and tell it to start at x equals 22 and just look at your y value. So I'm going to scroll up. There's that red line right there is my x value. Follow where it intersects my y. And I click on that point, and it says 22 is my x value and 54.171 is my y value. So my answer for that would be 54. I'd have 54 nickels when there were 2,200 minted. So that's the answer for C. Now, the next one's a little bit trickier. What it's wanting for my next one, it says a sample of 1,000 nickels contains 8. This is a y value. They're wanting to find an x value with this one. So what I'm going to do is go back to my Desmos here. I'm going to type in a y value instead of an x value. So I typed in y equals 8. And what I'm going to do is I'm going to go looking for that y value. So I'm actually going to go back to my front here, and there I'm looking where y equals 8. It's now a blue line, and again I click on that spot and click, and it'll bring up where that intersection is, and that's my answer. So remember, 8 was what I typed in, 5.951, and it says answer to the nearest tenth of 100 million. So we're going to do 5.95, so that's going to be round that 9 up to a 10 actually, which makes that whole thing a 6. So we're actually going to go to 6 100 million is the answer to that one. Okay? So I've got this here. The only difference between this problem, that's answer D, by the way. The only difference between this one and this one right here, the one we were just working on, 13, and number 14, the only difference between those two is number 14, your life will be much, much easier if instead of typing in your table 2001, 2006, 2008, if you realize it's been since 2000. So instead, use the X values of 1, 6, 8, 9, 12, and 13. Those are the years since 2000. That will make your life easier when you go to find things. And what that'll do is that'll give you that year after 2000. So if you find an answer for X values that's 15, that's 15 years after 2000, so it'd be 2015. You can use the actual years that are there. The only thing is when you go scrolling in Desmos, you're going to be up in the 2000s for your Y values, and it's going to make things look much larger than they are and much harder to find. Not impossible. You're just going to have to look a lot harder for it. So I'm going to end this video here. If you have questions, couple things. One, there is on that assignments list, there is a link to a video Miss Wimberly did going through lots of similar types of problems. She even does one specifically with years like this going through it. She goes through a number of them as well as a few more examples how to do it with Calculator and Desmos. So if you're needing help with that, that would be another great resource for you to use. It doesn't go through the actual problems on this paper, but it goes through ones just like it. So hopefully it should be able to translate over pretty easy. But as always, if you get stuck, please don't hesitate to email me, contact me. If I can't explain it, just telling it to you in an email, I'll fill it out on a piece of paper and send it to you and let you look at it. I will make a video. I'll do a Zoom conference with you if I need to. If you're not familiar with Zoom, it's like a web conference kind of thing that we actually go through and explain. Probably starting next week, I'm going to start up setting up hours, probably twice a day, somewhere around there, that you can actually cast with me online like that and actually get some one-on-one help with things. And I'll actually go through lessons. And just to check in, right now it's not going to be mandatory because I'm going to have a lot of other resources for you. But that is one way that we can kind of check in and see how you're doing. You can also ask me specific questions, and you can get live help that way, working towards getting that set up. So again, I hope everybody's doing good. If you are not, if there's anything you need, please don't hesitate to let us know so we can help you out. Have fun.